Okay, we're going to take a look at adding and subtracting rational expressions. Now, just as a reminder before I get to unlike denominators, if we have rational expressions that have the same denominator when we're adding and subtracting, just like when we're adding and subtracting common fractions, if the denominator is the same, then we keep the denominator in our solution and we just add together the numerators. So in this case, our numerator is t squared plus 7t plus 10. Okay, now looking at that, you're probably thinking, well, I know that that can be factored. When you get to this point, after you've combined the numerator, you always need to check, you always need to factor and then check to see if you can simplify. So when I'm factoring this trinomial, I see that I have t plus and plus. Now we need factors of 10 that add up to 7, which would be 5 and 2. Okay, so if I'm looking at these factors now, I have a t plus 5 in the denominator and in the numerator. So these two both will cancel out to simplify. And then what I have left in this expression is just t plus 2 over 1 or t plus 2. Okay, so that's what we need to remember. If we're adding and subtracting with a like denominator, we just keep that denominator and combine the numerators. Okay, all right. Now, if, however, we are adding or subtracting with unlike denominators, the first thing that we have to do is factor our denominators because we have to figure out what the least common denominator will be. Okay, so if I take a look at 6 and 9, so the 6 and the 9, I know straight away that they both have a common factor of 3. Okay, so for this one, we have 3 times 2, and then times a times b times b times b. And in this term, I have 3 times 3 times 1, 2, 3, 4, 1, 2. Oh dear, almost ran right off the board. Okay, so now I need to compare both of these denominators, okay? Because I want to find what they have in common so that I can find the least common denominator. Now I see they both have 3. They both have at least one a. This one has 3 b's and this one has 2 b's. Okay, so they both have at least 2 b's. Okay, now the easiest way to have a common denominator then is to take what I don't have on the right and put it on the left. Take what I don't have on the left and put it on the right. Okay, so then if I'm looking at this expression here, I'll just go like this just because it extends so far down. If I'm looking at the expression on the left, the right side has a 3 and 1, 2, 3 a's. So 3 and then a to the third. Okay, so I'm going to multiply this, 3a to the third. Okay, multiply the left side. Now, the right side over here is missing a 2 and a b. So I'm going to multiply this side by 2b. All right, so now if I'm looking then at my denominator, okay, so I have 3a to the third. I'm going to multiply it by 5, so that'll give me 15a to the third in my numerator. Whoops. And in my denominator, I'll have 6 times 3. That's going to be 18. A to the third times a, so a to the fourth, and then b to the third, minus, okay, 2 times 2b, so I have 4b in my numerator, and in my denominator, 2b, okay, so 2 times 9 gives me 18. I have a to the fourth, and then b squared times b is b to the third. Okay, so now we look down here, now we have the same denominator. Okay, so now we just need to combine our numerators. All right, so we'll have 15a cubed minus 4b over 18 a to the fourth, b to the third. Okay, because these are not like terms, we can't combine them together any more than they already are. So that's our final solution. Okay. Now let's look one more, an addition problem here. All right. Now remember, we need to start off by first factoring our denominators. Okay. Now looking at both of these polynomials here, I can see that they're not a difference of squares. There's not 3 terms. There's not 4 terms. So I'm going to see if I have a greatest common factor, which on the left side it looks like I have a greatest common factor of 5. And I'm left with x minus 5. And on the right it looks like I have a greatest common factor of 3. And then left with x minus 5. Okay, so if I compare the denominators in the left and the right, they both have x minus 5 in the denominator. Okay, so if I were to try to come up with a common denominator, it looks like my common denominator would be 5 times 3, or 15 x minus 5. 15 times x minus 5. Okay, so on this side, the right side is missing this 5 right here. So I'm going to need to multiply the right side of my equation by 5. And we already factored those. Okay, the left side of the equation, if we look at this denominator, is missing the 3. So I'm going to multiply the left side of the equation by 3. Okay. All right, so let's come down here. So now we have 3 times 2x, so 6x, and then 3 times this here. So we can, well, I mean, we could just go 3 times 5 and then x minus 5 like that, plus 4 times 5, which is 20, over, again, 3 times 5 times x minus 5. Okay. All right. Now I have the same denominator in both of these. Okay. What we could do, this 3 times 5 right here, we could just say that we know that's 15. Okay. We can just write that as 15. Okay. So I'll actually make that change when I come over here. All right. So my numerator, 6x plus 20. And again, these are not like terms, so we can't combine them any further. Over 15 times x minus 5. Okay, and that's our final solution. Since this 20 is added in to this binomial, we cannot cancel these. Okay, this is now one package up here at the top. This is a package and this is a package. Okay, they can't cancel at all. So our solution is 6x plus 20 over 15 times x minus 5. Okay, so go ahead and take what we did here and go to your review and see if you can complete the addition subtraction items there.